Today's the last lecture, unfortunately, for your honors chemistry class. And I know that this brings tears. We have one more lecture. This is the last one. However, it's not in your note packet, so you'll need a separate sheet of paper. Finals coming up here shortly. And we're naming acids. You need to know your 10 polys. So I know that I kind of feel bad that that I'm talking about this again, because you already know your 10 polyatomics, names, the charges, the formula. So I feel bad for having to talk about it again, because it'd be nice if we had a little poly quiz on Monday.
Yes, it would.
Yeah, we could do that.
Okay, now, are we seriously doing it?
We could. Yeah, I like that.
You should know these already.
Now, when you name the polyatomics, there's a possibility that we could remove some oxygens or an oxygen. If you remove one oxygen, remember that the poly that ends in ATE is changed to ITE. Okay, we talked about that a little bit earlier on. So this does not affect hydroxide. This does not affect ammonium.
Well, if you removed an oxygen from hydroxide, then it wouldn't.
Yeah, it'd be hydrogen.
And there is no oxygen in ammonia.
Correct. So those two we wouldn't have to change. And it doesn't end in ATE. So if it ends in ATE and you take an oxygen away, you now have an ending that ends in ITE. And the neat thing is the charge doesn't change. If you remove two oxygens, you still have that ITE ending, but you put hypo in front. In the opposite direction, if we add an oxygen, you leave your polyatomic as is and put the prefix per. So what's that?
Maddie said like a cat.
Oh. And then remember that when you do something to this, the charges do not change. Okay. The charges don't change when you add or remove an oxygen to a poly. Correct.
It's like
So
normal
you can do,
elements too, right?
To normal elements, no. Yeah. If you do change normal compounds, the charge will change. But with the polys, what's actually taking place is the quote-unquote thing that acts like a metal, like the phosphorus, the sulfur, the chlorine, it changes charge, but as a whole, the charge remains the same as it was. Yeah, Heidi?
Did you say the exceptions are ammonium and hydroxide?
The things that these rules will not apply to is hydroxide, ammonium, and acetate. Everybody else is free game. So really that narrows the list down to 7. So naming the acids, so that was just the polys. If we have an anion, what's an anion? Anybody remember?
Oh, negative.
Negatively charged particle, or in most cases, it's the nonmetal. So if our anion, or our polyatomic, or our nonmetal doesn't have an oxygen, we put the prefix hydro in front of the acid name. And then we drop the last syllable, or last 2 syllables, and put ic. Great example. If you have HCl, okay, is there an oxygen in this? No. So we're going to have the prefix hydro. Okay, the hydrogen is there. That tells us that we're looking at an acid. But with the chlorine, we're going to drop the INE and put ic, so we have chloric. And since there's no oxygen, it's hydrochloric acid. So again, if the nonmetal does not have an oxygen, you use the prefix hydro. If it does have an oxygen, well, that's the next slide, then you don't use hydro. Hydro means that there's no oxygen. And then drop the last syllable or last 2 syllables and put ic. And there again is the example, hydrochloric.
Oh, it is acid.
Okay.
Hey, where did you say something?
Hey.
Hey.
All right, so here we have our first one, HF. Let's hydrofluoric. So we have fluorine, and then drop the INE, put ic, so you have fluoric, and then put it all together. Hydrofluoric acid. And don't forget the acid name at the end. Okay. What?
What's it called when it's just, wait.
Again, there's no oxygen, so it starts with hydro. Drop the last syllable or the last 2 syllables and put ic. So you have fluorine, right? Get rid of the INE and put ic. And now you have fluoric. Since there's no oxygen, hydrofluoric acid. Here's another one. H2S. Now, before we name this, why are there 2 hydrogens in this one and there was only 1 hydrogen in the first one? Balanced charges. Good. Yeah. So the fluorine has a -1 charge, the hydrogen's a +1, so it's a 1-to-1 ratio. So we still balance charges, and in this case, sulfur has a -2 charge. So the 2 there, we don't call this di anything, because again, this is technically an ionic compound. So we have the sulfur, and drop the and actually put a little bit in there. So sulfuric, and then since there's no oxygen, what's this called? The whole thing. Hydrosulfuric acid. Good. Okay.
What if there's an oxygen?
So what if
Well,
we were to do
that's the
something-
rules here in a second.
Okay, what if we were to say like sulfate like over
If you said sulfic at this level, that's fine. Yeah, because you're following the rules. Drop the last syllable and put ic in there. Now, in AP, we'll talk about it, and you'll say it a couple 100 times, and you'll go, oh, it's sulfurous, or sulfuric, I'm sorry. All right, if the anion does contain oxygen, in other words, generally speaking, when it does contain oxygen, you're looking at a polyatomic. Okay, so the name is formed from the root name of the central element of the anion, or the anion name with the suffix ic or us. Okay. And even more importantly, there is no hydro in the name.
Yeah.
Okay, so when the anion name ends in ate, okay, like sulfate, carbonate, okay, continuing on with all the polys. If it ends in ate, remove the ate and put ic. Okay, so like for example, you have, and again I'm not showing the hydrogen yet, but if you have sulfate, drop the ate and put the ic in there, and then when you put the hydrogens on there to balance charges, you have sulfuric acid, H2SO4. Why is there no hydro in this name?
Because there's an oxygen.
Because there's an oxygen. Okay. So if you see an oxygen, do not write hydro. Okay. If you have a poly, and that's the only time that you'll have an ATE ending, is if you have a poly. Drop the ATE ending and put ic. Okay. It is cool. So here's an example. What's that called? Well, what's the poly? Let's go there. Nitrate. So drop the ATE and put nitric acid. Good. Okay. What is CO3? Carbonate. So what's this called?
Carbonate.
Carbonic or carbonic?
Carbonic.
Carbonic.
Carbonic sounds cool.
It does. It's in all of your soft drinks. It's good stuff.
It's in all the
Actually, it's in your drinking water as well. All right. If the anion contains oxygen, again, continuing on. In this case, if it ends in ITE instead of ATE, what's an example of something ending in ITE? Very good. So if you have, say, sulfate, but you removed 1 oxygen, so it's not sulfate, but it's sulfite, with SO3 with the -2 charge, then we drop the ITE ending and put OUS. Okay. So, sulfurous acid. Okay. Now the good news is, with your polyatomics, you only have 2 choices. It ends in ATE or ITE. Okay. Even if we remove 2 oxygens, it still has an ITE ending. Okay. Or if you add an oxygen, it still has an ATE ending. So you better get back then.
You can like race car in this.
No. So what's the name of this acid?
Oh,
What is it?
nitric acid.
Well, again, It's NO2, so we removed one oxygen from nitrate, so now it's nitrite. So it's nitrous. Okay. The ick only applies when you have an ATE ending. Okay. If we've removed an oxygen and now it's ITE,
So really
then
you
it's
just
a
have to
mess.
be careful to realize that.
The ick does, yeah. Does it end in ATE, then ick. If it ends in ITE, us. Here's another one. What's this called?
But
What?
the
Carbonus. Very good.
would it not be like?
Well, not what? What's the matter, Beth?
Mr.
Are you worried about the charges?
No, it's the if thing. And the last one.
Mm-hmm. It ends in ITE, so if it ends in ITE, drop the ITE and put OUS.
Mr. Craig, I have a question.
But
Yeah.
when did we learn that you put the IT in? Didn't we just learn that somewhere too?
Earlier, yeah.
What if
Okay,
we-
cool. I think I did.
What if we, got rid of, we said we had phosphate,
Mm-hmm.
and we took two oxygens away,
Mm-hmm.
we had hydrophosphate.
story time.
Not hydro.
Why wouldn't it be hydro?
Whoa.
Well, here's it. I think this is going down your path here. So looking at this, we have NO, which is two oxygens removed from nitrate, right?
Hypo.
Hypo, very good. So it's actually NO is hyponitrite. Well, it ends in ITE, so get rid of the ITE and put OUS. This is hyponitrous acid. So the hypo is not hydro, okay? Don't just say, well, it kind of looks the same. No, they're two different things. So hypo means that two oxygens have been removed. And it still has that IT ending from the first removal. Yeah.
So if it was just like HNO3, just be hydrogen nitrate?
If it were HNO3, then it would just be nitric acid. And we had that example earlier, and I can go back to it here in a second. We're almost there.
Oh, I can have that.
Okay. So what is the name of this? Or actually, let me ask you, what is the name of the poly? Ignore the hydrogen. So SO2.
Sulfite.
Hyposulfite, right? So what is the name of this acid? Hyposulfurous. Very good. Okay. And again, don't find yourself writing hydro when you have a hypo. Okay. And hypo can only take place if you have an oxygen in your compound. And that means the two have been removed. Alright, now here's a nice chart or table that shows the different examples using ClO3, which is chlorate. So if I add an oxygen, then I have perchlorate, and then we just call that perchloric acid. Remove an oxygen, remove two oxygens, then if you have no oxygens. So it's a pretty good table.